Balance the following reaction that takes place in acidic solution using the half reaction method. So, the half reaction method, first thing you got to do is be able to separate out what half is being oxidized and what half is being reduced. And you do that by looking at oxidation states. And so if we put in the oxidation states for each of these things, we can see that N has gone from +5 down to +2, and that Br has gone from -1 up to 0. So the oxidation half then is going to be Br, it went up, and it goes to Br2, and the reduction half is the NO3 minus to NO, since nitrogen went from +5 down to +2. And so in this case, reduction actually means what it sounds like. You're getting lower, or you're reducing your oxidation state. You are in the reduction half. Next thing you do is balance out everything except for hydrogens and oxygens. So in this case, the oxidation half, there is no hydrogen or oxygen, but there's 2 Brs on one side and only 1 on the other. So you put a 2 in front there. In the reduction half, there is 1 N and 1 N on both sides. We don't worry about the oxygen just yet, so we leave that be. Step 3 is balance the oxygens by adding water. So there's no oxygen in the oxidation half, so we leave that alone. But there's three oxygens on one side in the reduction half and only 1 on the other. So I'm going to add 2 waters here to balance out the oxygens. Next step is to balance out the hydrogens. Again, in the oxidation half, there's no hydrogen, so we can leave it alone. But since we added these waters to the reduction half, we need to add 4 H pluses, and the plus is important here. All these charges are important to the reactant side in the reduction half, so that we have an equal number of hydrogens on both sides. So now we have both half reactions are completely balanced. The reason why we can add hydrogens and waters where we couldn't do that when we did regular balancing is due to the fact that this takes place in acidic solution. So what we're implying here is that the acid actually participates somewhat in the reaction. So we can add these things as necessary. The next step is to balance out the charges by adding electrons. So in the case of this first half here of the oxidation half, there's an overall charge of 2 minus, or -2, because there's 2 Br minuses, and the Br2 is 0. So we need to add 2 electrons to this side, so that now the overall charge is, instead of being 0, it is -2 as well. There's nothing special about the number -2, it's just that that's what the other side happened to be, so we need to balance it out. In the reduction half, we see that we have 4 pluses, or 4 H pluses, so let's total of +4 -1, which gives us an overall total of +3. On the other side, neither of these things are charged, so we have 0. So to bring the +3 down to 0, we need to add 3 electrons to the reaction side. We can never add anything to make it more positive. We have to bring the higher number down, never the lower number up. So we're always adding negative things here. The next step is to make your electrons equal in both halves of the reaction. Remember that this is actually all just one reaction. It's not actually two reactions. We just have written it that way. So that the electrons coming out of one reaction have to be the same number of the electrons going into the other half of the reaction. So we can't have 2 appearing in one half and then all of a sudden it's 3 in the other half. They need to be equal. And so how we do that is very similar to finding the lowest common denominator in finding fractions in math class. So what can we do to make 2 and 3 equal? Well, if I times my 2 by 3 and my 3 by 2, I'll get 6 on both sides. So let me write out the new 2 half reactions down here. So 3 times 2 Br is 6 Br minuses, and they'll make 3 Br2s plus 6 electrons. In the other half, I'll take 2 times 3 electrons is 6 electrons plus 2 times 4 H pluses is 8 H pluses, plus 2 NO3s, make 2 NOs, and 4 H2Os. Now we're almost done. At this stage, once everything is balanced, all the elements are balanced, the charges are balanced, we recombine the two halves. So we take everything that's on the reactant side of both and everything that's on the product side of both and put them back together. It doesn't matter what order you put these in as long as all the reactants are on one side and all the products are on the other side. So 6 Br minus plus 6 electrons plus 8 H pluses plus 2 NO3 minuses make 3 Br2s plus 6 electrons plus 2 NO plus 4 H2Os on the side there. Now we're just about done. The easy part now is just getting rid of the things that are the same on both sides. So always when you're doing these, if you've done it right, your electrons should always cancel. You should always have the same number on one side as the other. Another note that I'll point out is that you should always be needing to add electrons to the product side in the oxidation half and to the reactant side in the reduction half. That'll be the same for any of these. So if you ever find you're adding electrons to the same side in both halves, you've done something wrong. So keep that in mind. However, back to the bottom here. Now we are basically done. We just need to rewrite the equation without the things that we have crossed out. 6 Br minuses plus 8 H pluses plus 2 NO3 minuses make 3 Br2s plus 2 NOs plus 4 H2Os, and we are done. One last thing I'll say is that the electrons should always cancel out. However, sometimes you'll be able to cancel out some of the hydrogens, and sometimes you'll be able to cancel out some of the waters as well. And we'll see that in the next example.